a proof, to show that, that equal to that. Okay? I'm not going to ask you about that proof, but just to show that that equal to that. But you know what? I want to walk you through two examples. And those two examples, one will involve discrete, the other one will involve continuous. And you know what we want to do? We want to build down all the way to correlation. Let me tell you this. When the examiner gives you a question and asks you to find correlation, you're actually going to do a lot. You know what I need to do? I need you to pay attention now. You're given this table. The fact that you're given a table means you're working with discrete. X is discrete, Y is discrete, and maybe the question actually said, find correlation or find covariance. Like here now, the question said, find the covariance of X and Y. And if I want to find the covariance of X and Y, what am I actually going to do? Okay, now if I want to find the covariance X and Y, okay, what I'm actually going to do? To find the covariance, based on what you see in the table right now, okay, and the covariance is actually this, expected value of the product minus expected value of S, expected value of Y. I need to first find the expectation of the product. How do I find the expectation of the product? Okay, summation. So like this is discrete. Expected value of xy. I'm actually going to have summation, xy, okay, xy, f of xy. Look at that. Okay, you can see that summation, xy, f of xy. Now, when you, what you're going to do is take a look at what I'm going to do. The first one is 0. When s equal to 0 times, when y equal to 0, multiply by 3 over 28. Plus, when s equal to 1, okay, times when y equal to 0 times 9 over 28. That is all what I'm actually going to do, and we'll do that all the way. That will give me 3 over 14. If I were you, try and confirm. I think I've shown you this the other time, how I got 3 over 14 from the last lecture. Let me see. Can you see that? Here. Can you see that? That's what I did. Here. That's what you're going to do. Okay? xy. Okay? xy, f of xy. What you have in the cell is the joint from 3 over 28 to 0 is the joint. So what you're going to do, you're going to start when s is 0, y is 0 times 3 over 28 plus when s is equal to 0, y is 1. You continue all the way. That will give you 3 over 14. And after you're done with that, you've gotten your expected value of the product. Now, if you get the expected value of the product, the next is to get the expected value of x. Expected value of s is going to be summation sg of s. How am I going to get that? You look at this. This is when s equal to 0, the function, the marginal, when s equal to 0, when s equal to 1, when s equal to 2. I'm actually going to multiply 0 here by 5 over 14, multiply 1 by 15 over 28, multiply 2 by 3 over 28, then I'm adding them up. Expected value of s is 3 over 4. I'm going to do the same to get the expected value of y. It's going to be 0 times 15 over 28, 1 times that, 2 times that, add them up. That will give me expectation of y. When I have expectation of s, expectation of y, and I already have expectation of product, then I can obtain my covariance. The covariance is going to be expectation of the product minus the product of the marginal means. And finally, look at what I got. I got negative 9 over 56. What that covariance is telling me is that the two variables are negatively, they move apart. But from this value, there's no way I'm actually going to know the strength of the relationship. This is only going to reveal the direction. It's not going to reveal the strength. Okay? Now, if I now want to get the correlation, I'm going to make use of this value. Don't forget, the correlation is actually the ratio of covariance divided by the square root of the variance multiplied by the square root of that. So which means you need to get the variance of x, you need to get the variance of y if you want to, continue. Okay? Now, how do we do this? How do we actually obtain this when I have continuous? I have this, okay, f of xy equal 8xy. Okay, so the fraction of x of male runners and the fraction y of female runners who complete in marathon races are given by this. Okay, but you know what? There's asked you to find the covariance of x and y. Do you know in the exam, if you're given a joint and they ask you to find the covariance of x and y, you're actually going to do a lot. The very first thing, you need to get the g of s. You need to get the h of y. Okay, because without you getting the g of s and the h of a function of s and a function of y, you may not be able to get the mean of s and the mean of y. Because in the covariance, you need the expectation of the product minus the product of the mean of s and the mean of y. And you know what? How do I get the expectation of the product itself? Okay, please pay attention. Okay, it's going to be integral, this guy. How do I get 8x squared y squared? Because initially, this is 8xy. Don't forget the expectation of xy in the formula. You're actually going to have this guy. In the formula, expectation of the product is going to be integral xy, f of xy, dx, dy. So the xy here has already multiplied 8xy before you even integrate at all, before you perform antiderivative. If you take a look at this, that would be 8x squared y squared. Does that make sense? That was y. That was how you get this guy here, the 8x squared y squared. Now, let's talk about the range. I needed to come to this. How do I determine the range in a situation where they said is 0 less than y, less than s, less than 1? Okay, if you want to determine that, if you take a look at the first antiderivative you're going to do, you want to do that with respect to x. Now you need to come here. What is the range of x here? It is between y and 1. Look at that. That was why I put y and 1. What is the range of y? The range of y is going to be between 0 and 1, not 0 and s. Because some of you were going to argue, oh, why lie between 0 and s? But the general upper bound is what you're going to choose. And that was why you see this guy here. I got 4/9. The moment I get the expectation of the product, then the covariance is going to be easy. I'm just going to plug in this guy here, minus, the mean of x times the mean of y. Then I got this as the covariance. Now, when I got that as the covariance, if I actually want to move to obtain the correlation, let's say they want me to get a correlation. Of course, for you to get a correlation, okay, you need a covariance. Okay, the correlation is covariance xy divided by square root of the variance of s, variance of y. Imagine you're giving a question like this in exam 2. They gave you a function x and y, and they asked you to obtain the correlation. You will do a lot. Okay? Now, after obtaining the covariance now, you need the variance of s and variance of y. And how can I get the variance of s? I need the expectation of s squared first, because to be able to get the variance of x here, okay, to be able to get the variance of x here, okay, to get the variance of s, I need the expectation of s squared minus expectation of s all squared. And to get the variance of y, I need the expectation of y squared minus expectation of y all squared, okay, to be able to get the variance of s and the variance. So which means, and I already know this guy, I know this guy, but I need to figure out this guy and this guy. And to be able to figure it out, okay, look at what I'm doing here. Expectation of s squared, okay, expectation of s squared is going to be integral s squared f of s ds. Okay, expectation of y squared integral y squared f of y dy. You see that? Okay, so if I get, my expected value of s squared is that, my expected value of y squared is that, I can get the variance of s. Now, because I already have expected value of x squared. The variance of x is going to be what I got for the expected value of x squared minus the expected value of x squared. That gives me 2 over 75. Then I'm also going to do the same thing to get the variance of y. After getting the variance of x, the variance of y, I'm just going to plug them in the correlation formula. Finally, this is what I got. But you know what? Correlation value is bounded between -1 and 1. Okay, bounded between -1 and 1. So when the correlation is very close to 1, okay, it means there exists a very, very strong positive correlation. When it is close to 0, of course, it's like maybe there's little or no correlation at all. So that is how we figure how that guy have. Okay, I put this as an exercise that you can try it out. I think we've done that in class. Now, you can also find expectation of the product when you have x, y, z. I want to ask a question for extra credit. Can somebody tell me if I want to figure this out, what am I going to do? I want to go ahead.
For the x, y, z triple integral, multiplying it by x, y, z.
X, Y, Z, there's something more.
Bound 0 to 1 for all three.
Yeah, if I hear you clearly, you said triple integral, x, y, z. What is the next thing?
Times 12 over 7.
Okay, which means generally times f of x, y, z. Then you're now going to say ds, dy, dz, right? Send me a message for extra credit. Good job. So they can ask you to find expectation of the product of so many variables. You're still going to do the same approach. Okay. You know, I attach I'm going to go to the new material for the week, and I need you to pay attention. Now, this is chapter 6. Let me tell you this. Chapter 6 will not be part of midterm 2. What is going to be covered in the midterm 2, we just finished it today. All the way, if you want to review for midterm 2, you're actually going to start from continuous function. Does that make sense? Continuous function, all the way to where we stop today. Now I can release practice question because, all the way to chapter 5. Okay, chapter 6 will not be part of midterm 2. Does that make sense? I want to welcome you to not midterm 2. Don't be scared. I want to welcome you to chapter 6 that we call function of random variables. Oh, let me do this. Maybe I shouldn't start this today because I said we should take our time. Let me use the next 10 minutes to entertain questions from you. Let's do an office hour now. Like, I want you to ask me questions based on what we've done before. I want to entertain questions. Like I said, the midterm 2 is not going to be cumulative. Midterm 2 will not be cumulative. Let me tell you this. What we did from last week up to this moment, I've seen one old question in midterm 2 from what we did from. So let me just say this. Midterm 2 will cover areas from continuous function up to today. I'm not going to start this today so that you'll be able to remember what I said. I'm not going to start this, okay? So up to today, Monday, October 27th, the midterm 2 will actually cover, all what we did from continuous function. But let me tell you this. When you take a look at all what we did from continuous function, they have, you need the knowledge of integral. You need the knowledge of calculus. So if I were you need to practice a lot. Because, let me tell you this, even in the practice question, if I give you some questions, mathematical question comes in different forms. Okay? Billions, we can set billions of questions from the same area. Okay? But you know what? The only thing I need from you is you need to revisit your knowledge of antiderivative. is very, very crucial. If you are still struggling with different kind of function, I'm not going to give you a complicated function, but if you know yourself better than anybody else, so if you are still struggling with how to perform an antiderivative, I will advise you meet with me during my office hour. Okay? My office hour, of course, is conducted every Tuesday and Thursday, okay, online. Okay, you can be anywhere in the world to attend my office hour. Do not hide your feelings. Like, I will advise you, I'm always going to say this. I will never deceive myself. It's not good to deceive somebody, but the greatest of that is when you deceive yourself. Because who are you going to report yourself to? Oh, I don't understand this. I think I still need some kind of clarification on this. Then I need to speak out. Because in the test, you're going to be by yourself. I want a situation where this time around, the test, the minimum will be 99%. But you know what? It's not going to be easy. Because you need to revisit your calculus. There's a lot of formula. A lot of formula. So because of that, I'm not going to start this new material today. But this new material that we're going to start on Wednesday will never be part of midterm 2. So for midterm 2, of course, you're going to start all the way from continuous function. Of course, where we let off in midterm 1. In the midterm 1, there is nothing that has to do with integral. There's nothing like that. But this time around, there's going to be a lot of questions that will revolve around integral. If there's anybody in this class who is struggling, it is absolutely fine. I'm fine with that. If anybody is struggling, but reach out. We're moving very close to midterm 2. And after midterm 2, the final exam is very close. Final exam is, has a very huge weight. Like I said, reach out. And let me tell you, my experience has showed that students don't want to reach out because it's like, I don't want to expose my ignorance. There is no any ignorance. Everybody has ignorance, including me. Nobody is perfect. But I can assure you, whatever you discuss with me will be treated with absolute degree of confidentiality. You can trust me. Because you pay for the service. It's not easy to pay for college in this part of the world. So you deserve to be served better. And that is the reason why do not hide your feeling. Problem, a philosopher said, and I quote, problem disclosed is problem solved. But I know some people would say, oh, I don't know whether I can trust people. That's why I can share what I'm going through. But you know what? I'm assure you that when you share that with me, I'm going to sit you down and I'm going to walk you through some things and you will understand. That's all I got today. Make sure you all stay safe. Have a very lovely day. Bye for now, everyone.